Welcome to Simplified Physics. This is the very first lecture on motion on the straight line or kinematics. Welcome again. The very first lecture on kinematics. In this lecture we may discuss about statics, kinematics, dynamics in brief, rest and motion, frame of reference, and basic concept on the kinematics. We may focus on the basic concept of the kinematics in this lecture. Let's begin today's lecture. Don't forget to subscribe and share. And for the lecture on the vectors, you may search on YouTube with this phrase: vectors has 1 simplified physics or vector has 2 simplified physics. Let's begin today's lecture. Let's begin with the lecture physics. Simply physics is a branch of science that deals with correct and precise description of the material universe. In fact, physics simply means the knowledge of nature. It is from the Greek word physic, so it means in a Greek or meaning of a Greek word, it's a knowledge of nature. Simply, physics describes the fundamental nature of the universe and how it works. Then what is mechanics? Mechanics is simply the branch of physics that deals with the study of forces, motion with their relationship. And let's discuss some branches of the mechanics. Statistic is simply the branch of mechanics that deals with the objects at rest. Whatever we study in mechanics are simply the design of bridges, buildings, and other structure. That means simply deals with the statics and deals with the objects at rest. Kinematics is the branch of physics that deals with the object in motion, but the cause of motion is not essential in case of kinematics. We are not without considering the cause of kinematics, cause of motion. That is the branch of mechanics is kinematics. Dynamics is the another branch. The branch of mechanics deals with the motion of the objects with the cause of motion. Something is missing here. Deals with the motion of the objects with the cause of motion is called dynamics. Statistics, kinematics, and dynamics are the branches of mechanics, and in this chapter we'll focus, or in this lecture we'll discuss only on the basic concept of kinematics. Rest and motion, very common term. Rest simply means an object is said to be at rest if it does not change its position with respect to surrounding. A cup on the table, a book on the table are the example. Some books are on the table are the examples of object at rest. What about the motion? If the body changes its position with respect to surrounding, that is called motion. A car is in motion. In the figure, a moving car, a walking person, a flying bird, etc. in motion. And in general, these two terms are relative terms. Rest and motions are relative terms. For example, a person is traveling through the car, with a driver. Then a passenger, or a next person sitting to the driver is at rest with respect to the driver. If a person is standing on the bus stand and a car is just passed away, in such condition, the passenger is in motion with respect to a person standing on the bus stand. So they are relative term. Similarly, a cup on the table with respect to earth, it is appears as rest. Suppose some person is looking from the space to the disk of, then as earth is moving around the sun, that means cup appears to be in motion with respect to a person on the space. So these two terms are simply relative terms, they are related to each other. Let's begin the frame of reference. Frame of reference means the place from which motion is observed. That is called frame of reference. And simply it's a coordinate system attached to the earth is called frame of reference. Suppose that an observer is under this plus mark, the distance of the first balloon will be 5 meter. More than 5 meter will be suppose 50 meter, and next balloon is 100 meter from the first frame of reference. Suppose an observer is in this balloon, then the distance of this balloon is different from each other. Similarly, that means the frame of reference determines the position of the body as well, isn't it? Simply the place from which the motion is observed, that is the frame of reference. So it depends, position of the body depends on the observer position, that means the frame of reference really matters. Let's begin the basic concepts of kinematics. The very basic term, distance. What is the distance? Distance is simply the actual part described by the body in a particular interval of time, that is the distance. Simply distance is the part covered, actual part covered by the moving body is the distance. SI unit is meter, and it's a scalar quantity, and it is always positive. What about the displacement? They are related terms, so I want to describe in a comparative form. It is the directional distance between the initial point and final position of the body, that after moving body. Initial position, SI unit of the displacement is meter, same, and displacement and distance have same unit and dimension. Scalar quantity, distance is a scalar quantity, but displacement is a vector quantity because it is a directional distance. Simply the distance from initial position to final position in a straight distance, straightforward distance, or directional distance between initial position to final position. So it's a vector quantity. Its value can be positive, negative, or 0. Okay, let's see. Take the reference. Note that the magnitude of the displacement is equal to the magnitude of the minimum distance between the 2 points. That means distance will be equal to displacement in some cases, but in general may be greater. Distance means, suppose a person is traveling from the part 1, that's a distance. Maybe part 2 also distance, part 3 as well distance. But displacement means only the directional distance between the initial position A to final position B, that is the displacement, and distance will be greater or equals to the magnitude of the displacement. And what will be the displacement of an object which follows the path A to B and returns back to B to A? A person has traveled from A to B and returned back to B to A. Displacement, initial position A, final position B, that means displacement is 0. Initial position A, final position also A, so distance is, displacement is 0. What about the distance covered by the object? It's a, if distance between A, B is x meter, distance traveled by the object is 2x meter. One more point, if a body is thrown vertically upward, what is the case? An object is thrown from the position A vertically upward, and after while it reaches to maximum point and returns back to the thrower, what will be the displacement? In this case the displacement will be 0, as initial position and final position same, but distance covered is 2 times of the maximum height covered by the object. And next term is simply the rate of distance traveled by the body. Of distance traveled per unit time is simply called the speed, or simply distance traveled by time taken is the speed of the body. Units after SI unit is meter per second, CGS unit is centimeter per second, and another unit kilometer per hour. And dimension is LT minus 1 or M0 L1 T minus 1. That means dimensions of the speed is 0 in mass, 1 in length, and minus 1 in time, and it is a scalar quantity. Let's come see the another term related to the speed. Uniform. What does uniform speed mean? An object is said to be moving at a uniform speed if it covers the equal distance in equal interval of time. That means in a first second, if its speed is 5 meters per second in second, after another 1 second it will be again 5 meters per second. In a third second as well 5 meters per second. In fourth second is will be 5 meters per second. Such speed of the body is called body is said to be in such body is said to be in uniform speed. What about the variable speed? If the body covers unequal distance in equal interval of time, or equal distance in unequal interval of time, is simply called variable speed or non-uniform speed. That means if the body in a first second, if in a very first initial time it has a speed of suppose 5 meters per second, in a second, after 2 seconds it will be 10, maybe 15, yeah, or 12, 11, whatever. It keeps on changing, varying. That is the non-uniform or variable speed. That means body is not in uniform motion. Average speed. Suppose the body is traveling with a variable speed. In such condition, total distance covered, body is not in uniform motion, then the average speed of the object is simply the ratio of the total distance covered by time taken to the time taken. That is called average speed of the body. What is the instantaneous speed? If a body is moving with a variable speed, it has different speeds at a different instant of time. Then at a particular instant of time, the speed of the object is simply called instantaneous speed. Suppose a body is in a very first second, body has the speed of 1 meter per second. In after 2 seconds, 5 meters per second. After 3 seconds, 7 meters per second. After 4 seconds, again return back to 3 meters per second, and so on. Then in a third second, what is the speed? It depends on the speed at a particular timing. That is at the third second, suppose it has a speed of 7 meters per second, then that speed is the instantaneous speed. That means at a particular instant of time, body has a certain speed. That speed is called instantaneous. At that instant of time is called instantaneous speed. What is the velocity? Velocity is the rate of displacement. Displacement per unit time is simply called velocity. Velocity is simply the displacement divided by time taken. And units are same as the speeds: meter per second, SI unit, centimeter per second, CGS unit, and kilometer per hour is another unit. Similarly, miles per hour and many more. Dimension same as the speed, LT minus 1 or M0 L1 T minus 1. And velocity is the vector quantity. What is uniform velocity? As the uniform speed, you can simply define an object is said to be in uniform motion. If a body is in uniform motion, or a body is said to be in uniform velocity if it undergoes the equal displacement in equal interval of time, same as variable velocity if there is the unequal displacement in equal interval of time, or there is change in magnitude, direction, or both. Such velocity is called variable velocity, maybe change in magnitude or change in direction or what can be sensed. That is simply variable velocity. Suppose a body is moving towards the east at certain velocity with a velocity of 5 meters per second towards the east. Then if change the direction, then turns to the south with the velocity of 5 meters per second. Same magnitudes remain same but direction changed. That is the variable velocity of with the velocity of the 3 meters per second towards the south. Now both the magnitude and directions are changed. In such condition, we can say that body has the variable velocity, average velocity. If the body is moving with the average, simply the displacements, ratio of the displacement by time taken simply gives the average velocity b bar. B bar is simply displacement by time taken. What is instantaneous velocity? An object moving with a variable velocity have different velocities and different instant of time. That's obvious. So velocity of the object at a particular instant of time is simply called instantaneous velocity. For a uniform motion, average velocity is equal to instantaneous velocity because there is no change in velocity, same velocity all body has. So if the body is in uniform motion, average velocity and instantaneous velocity are equal. And the instantaneous velocity is the limit of the average velocity of average velocity as time tends to zero, and it is equals to the instantaneous rate of change in position with time. That means displacement with time. That is simply called instantaneous velocity. Instantaneous velocity is simply given by ds by dt. And in terms of the language of calculus, in terms of the mathematics, limit of delta s by delta t, limit of delta s by delta t, that is delta s delta t, limit tends to 0. That is simply called the derivative of the displacement with respect to t. Derivative of the displacement with respect to this term is called derivative of the displacement with respect to time t. Okay, let's compare speed and velocity. Simply speed I am comparing here. It is a distance traveled by the body per unit time. Distance speed is, and displacement of the body per unit time is velocity. SI unit is, both of them have same unit, same dimension, but the speed is rough scalar quantity and velocity is the vector quantity. It is always positive, but velocity can be positive, negative or 0, and speed is greater or equals to velocity. Velocity is always lesser or equals to speed. What is an acceleration? An acceleration is rate of change of velocity with time, interval divided by time interval gives the acceleration of the body, and units are meter per second square, centimeter per second square, kilometer per hour square, or miles per hour square, and dimensions CLT minus 2 or M0 L1 T minus 2, or it is a vector quantity. And direction of the acceleration is same as that of the velocity. That means simply the velocity by time taken, simply it is also a vector quantity, and direction remains same as that of the velocity. The acceleration is positive if the velocity is increasing, and is negative if it is decreasing. If velocity is decreasing, it is negative. If velocity is increasing, acceleration is positive. And the negative acceleration or decreasing acceleration is simply called retardation or deceleration. Negative acceleration or decreasing acceleration is what is uniform acceleration? An object is said to be moving with a uniform acceleration if velocity changes in equal interval of time. equal in equal interval of time in magnitude and direction. Both magnitude and direction equal changes equal amounts. That is in magnitude and direction. That is called uniform acceleration. What about a variable acceleration? It is obvious that an object is said to be moving at a non-uniform or variable acceleration if there is change in velocity, magnitude, or both direction with time. That is called variable acceleration. That means varies with time. Velocity varies with time. Change in that is change in change in velocity in magnitude, maybe in magnitude, direction, or mode keeps on changing. That is the variable acceleration. Average acceleration is simply the change in velocity divided by time interval. That is the delta v by delta t gives the average acceleration of the body. What is instantaneous? That are not obvious now. Instantaneous acceleration means an object moving with the variable acceleration has different acceleration at a different instant of time. That means at a particular instant of time the body has the particular acceleration. That is simply called instantaneous acceleration, or the rate of change of velocity at a given instant of time is instantaneous acceleration. And instantaneous acceleration will be same as average acceleration if it is moving with the uniform acceleration. And the instantaneous velocity is given by limit of rate of change of average velocity with time, and it is the derivative of velocity in terms of time. Simply in language of calculus, it is acceleration equals to derivative of velocity after time, as before. And this is the end of the lecture. Thanks for watching.